On to the exercises. Do people with a family history of mental illness seek treatment more often than those who do not? All right, so let's go ahead and look at this. So we're going to use a cross tab here. And so those with a family history of mental illness, so let's say family history, and then columns, they seek treatment. That's this column right here. All right, so this is a little bit difficult to understand. All right, so so we see that those with no family history of mental illness, we can see that, do they seek treatment more or less often? Well, so it looks like there's quite a bit more no's than yeses. For those that do have a family history of mental illness, then it looks like there's quite a lot more that seek treatment. So this is actually looks very significant. And if we normalize over here across the index, and I like to round, of course, it's one of my favorite things to do. All right, so of those that have no history of mental illness, 63% do not seek treatment. But of those that do have a family history, only 25% say no. So it's quite a large difference and almost an entire flip of the percentage. So it looks like it's very significant whether or not you have a family history, whether you yourself will seek treatment, at least in this particular data set. All right, number 2, find the total number and ratio of employees that seek treatment for companies that provide health benefits versus those that do not. Okay, so again, we're going to be cross tab, the ones that seek treatment for those companies that provide mental health benefits. So does the company give benefits? That's this question. If we go back up here, let's look at the data dictionary again, MHDD. You have to look at the data dictionary for this. Yes, does your company offer mental health benefits? So that's the benefits column. And find the total ratio number of employees that seek treatment. Okay, so we're going to look at that treatment column again. Okay, so here's the total number, and then the ratio was just the same thing, but we are going to say normalize equals index and round, of course. All right. So we'll just skip the ones that don't know and look at the no yes. So of the ones that do not give a benefit, it looks like it's just about 50-50. The ones that do give a benefit, looks like there's many more yes, so it's about a 2-to-1 ratio. So what this data is telling us is that those companies that do offer mental health benefits have employees that actually will seek treatment more often. All right, number 3, it's also good to say that it's hard we don't know the reason if this factor is driving one or the other. There's many explanations that can lead to this, so it's hard. This is just getting the raw data, not necessarily interpreting the results, which is a much more difficult task. All right, number 3, you can provide a list of multiple columns to both the index and columns parameter of the crosstab function. So we saw that. Put country and number of employees in the index. All right, let's do that. So we'll say index equals country and number of employees. That's this column over here. No employees, number of employees. So we need to put a list over here. Okay. And then we have columns over here is equal to seeking treatment again. All right, so there we go. That's all we are trying to do. So it's a breakdown. So in Australia, of companies that have 100 to 500 employees, we have this, data. So 2 seek treatment, 2 did not, 4 did seek treatment. This is actually where making it a categorical and making an ordered categorical would make more sense. So we can actually do that. So I did not do that above, but now I'm looking at the data again, and I think it's a good idea to do that. So we say PD. First of all, let's get the unique values. So here we go. So it is categorical, but it's not ordered categorical. And we need to put this in the right order. And then let's move 1 to 5. All right, so let's see if that's right. 1 to 5, 6 to 25, 26 to 100. Okay, looks good. So we'll make that a categorical D type. Say ordered equals true. And this is just for laziness, we'll say this is DT, data type. And then we will change this. We will say MH of the number of employees. I'm going to just overwrite this column here. Dot as type DT. And then, so I just overwrote the data type, and now it'll show up in the right order. So that is a good one to do, an ordered categorical. So we can have them show up like this. So it's a lot easier to read. All right, number 4, read in the bikes data set and find the distribution of total trip duration by gender and events. Okay, so hold on, there's a lot to do in one go. Let's read this in. Okay, read in the bikes data set. Find the distribution of total trip duration by gender and events, normalized over all groups. Okay, so we're going to see like what portion of all rides is done by males or females. So let's do pd.crosstab. Say index is bikes of gender. Columns are bikes of the trip duration. And this time we have to aggregate. So no, gender and events. So I did that wrong, events. And then what we're aggregating, so the values here are that trip duration column. And then the ag func is going to be, we're actually going to sum up the ag. So let's just do this first. So you can say what, yeah, so we're trying to answer the question, what percent were done by males on a clear day? Right, okay. And then we want to normalize, and we're going to normalize on the columns this time, like this. Okay, great. So the columns will add up to 100%. So on a clear day, 72.8% of the entire trip was done by males. So that answers that question. Right, so when it's raining, 77.4% of the trip is done by males. So you can see which ones maybe favor males versus females. What is the highest one by male? So in the snow, looks like there's more males, 86%. When it's foggy, this is the females highest, I guess, partly cloudy and foggy. There are more females riding than other times. All right, so that is it for the exercises.